questions and try to answer them as much as I can. First is definition of scalability. So what do you mean by scalability? Like, so whenever somebody gives you a requirement, nobody calls out the scalability portion of it. It falls under what we call as a non-functional requirement. Nobody says your operation, when a product manager comes and meets the engineering team, nobody comes out and says your SLA should be 50 milliseconds. So most of scalability is abstracted into what we call as non-functional requirement. So when you say your systems are more scalable, at least what my definition of scalability is, you maintain your current SLA. So if your current SLA is, say, 30 millisecond or 50 millisecond, in spite of taking, if you're taking, say, 100,000 web requests at a given point of time, and then now you scale it to, say, 500K web requests, your SLA should not deteriorate. If it's 50 millisecond, it continues to be in 50 millisecond. And also the fact you have to maintain SLA even if you add more features to it. For example, if your pay API takes, say, 50 milliseconds for 500K requests at a given point of time, even if you add incentives, promo codes, etc., your SLA still maintains at, say, 50 milliseconds. And the reason for that is systems that are downstream, upstream, that are kind of interacting with you, your peer services, expect that level of SLA from you. Once you establish that these things are very hard to change, unless you're kind of improving your performance. Like if you're going down, people are happy, but most of the times, if you try to go up, there'll be a lot of resistance. And one that goes without saying is if you're adding more nodes to the system has to scale. So it's like you definitely should see an increase in performance by adding more nodes. It need not be linear. I mean, it's very difficult to get a linear increase, but ideally you want to have that. And then your system should be able to handle heterogeneity. What we mean by that is, for example, if you have a system upgrade, like you have a kernel upgrade from 2.4 to 2.8, or your machine memory goes from 8 to 16, whatever, 64 GB, whatever be the case, right? You don't have to rebuild your service just to run on that particular type of hardware. Ideally, your system, your services should be independent of hardware. So in case even if operations tomorrow decides to build something different completely, your software should be able to handle it. And the other thing is your services have to be, have to take on failures. I mean, failure is a given. Systems will fail. That's the fundamental tenet. It's a question of how you manage your failure cases. That's where scalability comes in. And of course, all this, when you're adding more nodes, doesn't mean it increases your operation cost. So any scalability solution, if it involves a lot of operational expense, I mean, orgs can still do it, but that's not an effective scalability solution. So that's what we mean by scalable systems broadly. So on this slide, I'm going to talk about